And so of course, if we want to do the standard deviation, which is just, oops, not sigma squared but sigma, it'll be the square root of the variance. Okay? And of course that's sort of a silly way of writing that. Let's just say square root of the variance. Okay? Alright, so let's do that calculation for this distribution. To do that we'll need, just like we did for frequency distributions in the first module, we'll have something analogous to fx. In this case that'll be x times p of x, and then we'll need a column also for x squared times p of x. Alright, so x p of x, 0 times 0.05 is 0, 1 times 0.1 is 0.1, 2 times 0.2 is 0.4, 3 times 0.3 is 0.9, 4 times 0.2 is 0.8, 5 times 0.15 is 0.75, and we add those up when we get 2.95, and that's our average. Right? It's the summation of the x's times the p of x, so that's mu. Alright, and then a column for x squared p of x, so 0 squared times 0.5 is 0, 1 squared times 0.1 is 0.1, 2 squared times 0.2 is 0.8, 3 squared times 0.3 is 2.7, 4 squared times 0.2 is 3.2, and 5 squared times 0.15 is 3.75. We add those up and you get 10.55. Alright, note that's sigma x squared times p of x. Okay, and let's go below and talk about the mean of that distribution, the expected number of increases in the stock market over a 1 week period. Alright, mu is either the expected value of x, which is the summation of x times p of x, and that value is, from our calculations above, 2.95, just under 3 expected increases. Let's first get the variance. Sigma squared is sigma x squared px minus the mean squared. From above, that's the addition of the last column in the table above, sigma x squared times p of x. That's 10.55 minus the mean, 2.95 squared is equal to 1.8475 to be precise, okay, by my calculations. Alright, and so the standard deviation is the square root of that variance, 1.8475, and the value of that, and this is a number that we'll round off, 1.359, 4 significant places. Remember your significant places, 1, 2, 3, 4 significant places. Alright, so that's the standard deviation of that distribution. Now at this point you're thinking, why do we do that? In a little while it'll be important for us to know the mean and standard deviation of certain types of probability distributions. Okay, and this is, in this module actually, is where we sort of tie the first two modules together. When we talked about the first module means, standard deviations, and lots of other things. In the second module we talked about probabilities, sort of verged into probability distributions. Now we're going to look at probability distributions, the mean, standard deviation, all that sort of stuff. But to be honest, we'll put a lot of focus on the probabilities. Okay. Let's now look at another example. Let the x be the number of computers, desktops, sold in a store on any day. And let's assume that the number of computers sold is limited to the range 0 through 6, and that the probabilities of occurrences are the 10% probability of no sales, 20% probability that they sell one on a day, 30% chance that they sell two, 20% chance they sell 3, 10% chance they sell 4, and 5% chance they sell 6, and again 5% chance they sell 5, and then 5% they sell 6. Alright, and the probabilities when you add all those up adds up to 1, as it should. Alright, so that's probability distribution. Alright, what I want you to do is to find the following things, pause the video, and then check your answers against mine. Okay. Alright, let's find the probability of selling more than 2 on a particular day. Find the probability of selling at least 4. At most 3. No more than 2. More than 1. Okay, and let's then find the mean and standard deviation of that distribution. Of the number of sales of computers on any one day. Alright, at this point I suggest you pause the video and do this problem, and then when you're ready, continue the video and watch my answer. Alright, I'm back. I've done the calculations that we require for the mean and standard deviation. Alright, as you can see, I've done my columns for x p of x, x squared p of x, so that I get the summation of x p of x, the 2.35, which then becomes the mean, and then I have the summation x squared p of x, the 7.85 that we use in the calculation of the variance. Okay, so the mean 2.35, the variance 7.85 minus the 2.35 squared is a 2.3275, right, for the variance. And then the standard deviation, little sigma, square root of the 2.3275, and the answer for that is the 1.526. Okay, At that point, we can go and find these probabilities. Alright, part A, probability of selling no more than 2 would be x less than or equal to 2, and let me make that clearer. X less than or equal to 2. Less than or equal to 2, of course, is these numbers here, and that adds up to 0.6. Right, 0.1 plus 0.2 plus 0.3 is 0.6. Part B, at least 4. At least 4 means 4 or more. We're talking about these probabilities here, and that adds up to 0.2. 0.1 plus 0.05 plus 0.05 is 0.2. At most 3. Right, it's like the first one, no more than 3, you could say. It's less than or equal to 3. At most means you can't go any higher than 3. Okay, so we'd add up those probabilities, and that's 0.36, that's 0.8. Note, not that it's extremely important, but this is the complement of the one above, x greater than or equal to 4. Right, 1 minus 0.2. Sometimes, as you'll see down the road, sometimes useful to be able to calculate complements. Sometimes a complement is easier to find than the thing itself. Alright, D, no more than 2. Alright, x less or equal to 2, no more than 2. It's the same as the first one, right? That was sort of silly. Alright, and E, more than 1. Right, greater than 1. Those probabilities. As I said a little while ago, while we could calculate that, it's sometimes easier to find the complement. Alright, complement is 0.3. If that's 0.3 there, then this has got to be 0.7 here. Okay, since the whole probability distribution adds up to 1. So the answer to E is 0.7. Okay, that's the end of that question.